Okay, let's try this here. Now this one here is, I'm noticing I have an exponent of 4. Notice I have an exponent of 2. I know that 4 is 2 times 2, so therefore I'm going to use u substitution. Remember, with u substitution, just off to the side, let me know what you're using for u. This right here is always going to be what your u is. So let u equal to x squared. I'm going to rewrite this as u squared minus 16u plus 63. Okay. Again, now we have a quadratic. Two numbers multiplied together that add up to negative 16, but give me 63. And that would be negative 7 and negative 9. So negative 7u minus 7u minus 9. Okay, you're not done. You're going to reintroduce your x squared here. You're going to re-plug in x squared. So x squared minus 7, x squared minus 9. 9, again, is one of those numbers that needs to jump out at you. 7 is not a perfect square, so we're done with this one. But this can be factored further because I can rewrite x squared minus 3 squared, because 3 squared is 9. Because this is a minus, very specific, this is a minus, we have the difference of two squares. This can be rewritten as x minus 3, x plus 3. And I'm going to bring down my x squared minus 7. The other ones are linear, exponent of 1. 7 is not a perfect square, so we're leaving it. And that is your final answer. Moving on to number 12. Immediately I see that I have two x's here, here, and here. So I'm going to factor out an x. I'm left with x cubed minus 1. 1 is one of those numbers that needs to jump out at you. So in reality, what I have is x times x cubed minus 1 cubed. We're going to forget about that x just for a little bit. I'm going to just write it here as my answer. So I know that x is in my answer. But I'm going to work with this part here. I know this is the difference of 2 cubes. So we're going to go back up here. Just like in number 9 when we had a difference of 2 cubes, this is what you're going to use to factor. So I have here x is a, 1 is b. So x minus 1, x squared. So same, always different. So 1 times x is x. Always positive. 1 squared is just 1. This one right here always will not be factorable further. You're done when you have cubes. So I'm going to bring this into my answer, x minus 1, x squared plus x plus 1. This is linear exponent of 1, and you're done. All right, number 13. Number 13 is, let's see, I see an x on all of them, so I'm going to factor out an x first. But I'm thinking, do I really want to do that? Well, let's see if this works. If it doesn't, we can just redo it a different way. My thought was maybe this is grouping, but we'll see. So I pull out an x. I have x cubed minus 11x squared. Then I have minus, there shouldn't be parentheses there because I'm just factoring out an x. I'm not grouping anything yet. So minus x plus 11. And then let's see if grouping works. Remember, answer. If you factor anything out like an x, make sure that you already have it in your answer. I'm going to try grouping inside here. So I'm going to say, here's my x. In here, I can pull out an x squared. So I'm left with x minus 11. And then I'm going to pull out a negative 1, and I have x minus 11 here, which, again, I'm very happy that grouping works. So in my answer, I'm going to write x minus 11 one time. And I'm going to write x squared minus 1. But again, 1 jumps out at me. So I'm going to just continue factoring that 1 as 1 squared. So this again is the difference minus the difference of 2 squares, which is x minus 1 and x plus 1. So in your final answer, I'm going to cross this out since it's not our final answer. Our final answer is x times x minus 11 times x minus 1 times x plus 1. And that's your final answer for number 13. All right, just a few more. State the possible rational zeros. Keyword here is possible. We like the word possible because it saves us a lot of steps and work. Okay, whenever it says possible, you need to use the rational roots theorem, which states take the number, the coefficient, the constant, take the constant over the coefficient and give me all of the factors of those. So in this case, we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Factors of 6 is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now, this is not all of your factors, okay? We need to put them as fractions, rationals, fractions. So you're taking every single numerator on top of every single denominator. So we're going to say we have 1, 2, 3, 4 numerators. So 1, 2, 3, 4. And then next one is going to be our 2's. 1, 2, 3, 4. Next we have our 3's. 1, 2, 3, 4. Then we have 6. 1, 2, 3, 4. Now the reason I'm doing 4 of each is because I have 1, 2, 3, 4 different numerators, and each numerator has to be on top of every denominator. So now I'm going to go back in and I'm going to write each numerator on top of these denominators. So I have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. I'm going to do that for all of these as well. Oops, I think I just started counting in my head. So this plus or minus 3 should in fact be plus or minus 4, and then plus or minus 8, and then plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now, you only need to write them once. So once you've simplified the fraction, if you have multiple fractions that are the same, just write it one time. Don't write, 1 numerous times. For example, this simplifies to 1. So I know I'm going to have a plus or minus 1. But I also know that 2 divided by 2 is 1. So I'm not going to write it again. And I know that, I think that's it. Okay, so that one's done. Then we have 2 plus or minus 2. Do I have any other fractions that simplify to 2? 4 divided by 2 is 2. Let's see here. Oh, that one's done. Then we have 4 plus or minus 4. Is there anyone that simplifies to 4? We don't. Then we have plus or minus 8. Is there anyone that simplifies to 8? No. And then we have plus or minus 1/2. Do I have any other ones that simplify to 1/2? Oh, I think I did have one that 8 divided by 2 is 4. So I already have a 4. So I'm looking for 1/2. 1/2. 1/2. 1/3. So 1. Oh, so I see another 1/2. So then we have 1/3. 1/3. 1/3. 1/3. And you just kind of keep going until you have listed every single one of them. Then we have 2/3. And remember, each one is plus or minus. Plus or minus. Now, I don't care about like the order, like saying, hey, 1/6 is smaller than 8/3, so it belongs closer to the left. Don't worry about that. As long as you've listed this, we have a 2/3 here, and this is 2 goes into 8 4 times, and 2 goes into, this is 4/3, and we have that already, so we're done. Okay, so just be careful. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 10 plus or minus roots. So here are all of the possible ones. Now again, we like all the possible ones because we don't actually have to figure out which ones are the root, which ones work. Just as long as you list